Good afternoon, everybody. Thanks for coming in after lunch. For those of you who are on your phones, you are hitting a data center. And we're going to talk a little bit about data centers today. How many of you use Grok? You know what Grok is? Claude? Gemini? ChatGPT? There you go. The explosion of those applications is what's fueling artificial intelligence, at least for the last couple years. What goes on in the next couple years may be quite different. I'm old enough to remember in 1994 looking at the Mosaic internet browser and going, things are about to change. I think we're in a similar situation now. But I'm really not here necessarily to talk about those applications so much as I'm here to talk a little bit about money and why the coming future of where we're going with AI data center and site selection probably is a GIS problem. It may not be a complicated GIS problem, but it will be very important for people who are working in economic development. Anybody here with an economic development group? Great to have you. Thanks for being here. Is it really a GIS problem? Well, it's site selection, and that's really what the crux of the matter is, and I'm going to talk about it. It's not really a great problem. I'm here more to educate you about the requirements that are going to be needed for data center site selection. It may not be some things you've heard about, but at least I want to bring them to your attention. But there are two other reasons that I think it's critical, and that is that there is way too much money being thrown around by many different organizations, some of which you've heard of, some of which you probably haven't. Obviously, you've heard of the hyperscalers, Microsoft, Meta, Amazon, Google. You can throw in Intel and a bunch of others. Then there's the investor community. You cannot miss the amount of money. I listen every morning to CNBC, the financial news network. Every other story is about the money that is being poured into data center development. This is just a little bit about the money. $80 billion, it's not a small amount of money. That's just from Microsoft this year. They're putting money into getting, securing contracts for electricity. You may have heard they did a deal with Constellation Energy to restart 3 Mile Island, if you're old enough to remember what happened to 3 Mile Island. $150 billion by Amazon. That's over the next coming years. I think that's a low number. And Meta, $65 billion. And they are seeking to add a number of contracts for electrical generation. What's different to us in GIS, and I didn't explain who I am. I work for a company called CoreLogic. We are a property intelligence and real estate company. I spend most of my time in Pine Knoll Shores. If anybody's here from Carteret County, sometimes I spend my other part of my time in Wake Forest. I've spent about 45 years in GIS, and I started my career. I'm now a recovering remote sensing geologist. The money here, the things that we are not familiar with as GIS people is how data centers are measured, and they are measured in megawatts. Okay? The electrical generation capacity needed to run these things is incredible. The other thing to talk about AI data centers is jobs and economic development. I can tell you, I've only been a resident of North Carolina for 6 years. We are in competition with other states, and I'll get to that in a little bit. This is the amount of money and jobs created over the last year. Some of the data is not represented, it wasn't available, but you can see Texas, $13 billion. Virginia is known, especially up near Dulles Airport in Ashburn, known as Data Center Alley. There's a few data centers up there, and I'll talk more about that as well. Again, not any information I found on North Carolina, but I do have some other things I can show you. But the point is that there's a lot of jobs being created in construction, in development, and economic development directors are trying to attract data centers into their own communities because of jobs and construction. Okay, two limiting factors about data center. I alluded to one of them, that's electricity and power. To run today's normal data centers, every time you order something from Amazon, you hit a data center. Every time you're on Instagram, you hit a data center. They take up about 5 to 50 megawatts of electricity. Those are relatively small numbers. To site an AI data center, we're talking 10 times the amount of electrical requirements. And there's a reason for that, and that's the GPUs that are being stuffed into the racks that are being stuffed into data centers. The other limiting factor is land. That's why I'm here from a real estate company. Data center campuses require about 10 acres, 100 acres. If it's a big facility, it's land. There's a lot of land required if you're going to build one of these things. Okay, to me, real estate is a data of information arbitrage. If you know where there's land, if you know how much it's valued at, you're going to want to promote that land. And if the data centers find you first, that's great. If you have the information at hand, that's great. But those who know it first wins. And this is a quote from the guy who was one of my mentors. He wrote a book several years ago called Profiting from a GIS, but his latest book is called AI Applications in Real Estate. I would recommend it. The other thing beside land is power, and again, I mentioned that briefly. Cooling GPU chips and the amount of water needed to cool them is substantial. I didn't realize this, but until I went to a conference, they're now submerging GPU racks in water to cool them. I thought that was kind of electrically impossible, but I'm not an EE. Today, data centers consume about 4.4% of all electricity in the United States. That's about 25 gigawatts. In the coming years, we're going to be at least double that. This is where we run into this electricity deficit. If you look at this report from McKinsey, we're going to fall about 15 gigawatts short in 5 years. Now, just to give you a sense of what a gigawatt is, this is the Alan Vogel nuclear power plant. The last unit of Vogel went online a year ago in May. It was only 1 gigawatt of nuclear power. You can try to add more nuclear power plants. It's a 15-year process between permitting, construction, the not in my backyard syndrome. All of that is going to be a problem. Okay, 1 gigawatt can power about 750,000 homes. They are now projecting that even a single data center may require an entire gigawatt. This is a lot of energy that's being consumed at this point. And then there's land. This is a graphical representation of Meta's AI data center in Northeast Louisiana. I can tell you there is nothing in Northeast Louisiana except open land. This will require, this plant is currently being built. It's going to take up over 2,200 acres of land. One of these buildings alone is probably 10 to 50 acres of space. Projected 500 direct jobs, 1,000 indirect jobs. This is why economic development directors want data centers where they are. They want to attract jobs, and they want to attract the tax dollars that comes with those jobs. Okay, is this a GIS problem? Well, there's all the U.S. power plants in the country. There is a parcel fabric right over here in Winston-Salem. You put the two together, and maybe you have something interesting to look at. Here's your competition, Culpeper County, Virginia, just south of Washington, D.C. They are actively trying to tell people, come on here, we've got the land, we've got the availability, we want people to come. In the upper left-hand corner is the Equinix data center. They've got this area, which is designated as a technology zone, where they want not just AI data centers, but manufacturers as well. So there's the aerial view of the McDivitt Drive Technology Zone in Culpeper. Cielo Digital is putting 1.4 million square feet there on McDivitt Drive. And then here is an example of other rural counties attracting new data center development. You can list them there, Meta, Microsoft, Google. They're all going to these rural areas because of the land availability. Okay, why rural counties? And there's a reason for that. You're familiar with large language models that are the basis for ChatGPT and others like Grok and Claude and Anthropic's version. They just require more space. They're trying to shove in as many NVIDIA chips. You may have seen announcements about NVIDIA, the Blackwell chip, now the Rubin chip. We're talking a lot of power needed to create large language models to be trained. And they're being trained for inference models and then eventually agentic models. Inference models, the way I look at inference models, are very much the way I would expect you to generate a typical geospatial query. Find me all of the available office space, that's classed as Class A office space, between 4th and Main in Peoria, Illinois. That is a true semantic query that we ask every day of geospatial systems, right? But that is really what inference models will eventually do in the AI world. So you want to be able to train your model to get to something that will, to do a query that will actually do something for you and eventually answer a question, answer a geospatial question, without you having to learn SQL statements or the complexities of ArcGIS. The other reason is latency is not an issue. What I mean by that is in order to train a model, it's got to go somewhere. And that's generally communicated by fiber optic cable. In that graphic I showed you of Meta's data center in Louisiana, there are 8 million miles of fiber optic cable. That's a limiting factor as well, but not for LLMs. Inference models, and that's the caveat, is that they don't require as much compute power. Once you fill in the put the LLMs in place, the inference models don't require as much electrical capacity, but they do require you to be closer to the source of where the need is, like robotics, healthcare, and geospatial intelligence. This is why Northern Virginia is this hub of data centers, because they're closer to the federal government and all the applications that are generated there. Okay, now, what do you need to locate a data center in North Carolina? Well, these are the 5 elements that I think you need. We've spoken about land, power, fiber, transmission and distribution, and then there is the issue of resilience. I haven't talked a lot about that, but again, you don't want to locate a data center on a fault line or where I live in Pine Knoll Shores, North Carolina. It isn't rocket scientist, but obviously I think it is geospatial science. Here's the directory in North Carolina. There are 41 data centers today. That's probably about how many there are just in Ashburn, Virginia. 14 announced, 9 under construction, mostly by Microsoft in Maiden, Newton, and Conover. Obviously, Microsoft and Google, they're obviously putting in a lot of money into North Carolina. Okay, here's where they are. Now let's start the GIS problem. That's these are the names. Some of you may be familiar with where they are. I mentioned Microsoft is up there in Maiden, obviously the ones around Charlotte and the major metropolitan areas. So you want to set this up as a GIS problem. Here's the broadband fiber trunk lines. The data that I'm getting is from a company called Landgate. You could probably find similar data on openinfrastructure.org. It's a great source if you're not using it. This is a mess. This is the transmission and distribution lines. High transmission lines are needed. And then this other mess of where all the power plants are. The nice little orange triangles are mostly solar, which is a great thing. But solar isn't going to make up the need for electricity. It's going to supply some of the hyperscalers want the resiliency, but they're not going to make up the difference. This is where, unfortunately, you're going to roll back into resources like natural gas. Red triangles are just locations of, I just went out of my mind, substations. So it's a mess, but it's a typical GIS problem. This is just the example near Lenore. This is Google's data center up there. You can see the location of substations, the high power transmission lines, and then the backbone infrastructure. Google's already announced expansion of this on Lynn Haven Drive. That's according to the Charlotte Observer. So you put all these things together, it's not really a hard GIS problem. Where am I going to look for? High transmission lines, good distributions, substations, power generation, and then access to where the people need it most. But this is an example of a data center in a rural area. And this is the one in Maiden where Apple's plant is. And you can see it's adjacent to a solar farm that's really specifically for that data center. Okay, is it really a simple GIS problem? Kind of, right? So just take this, I'll make sure I've got time. Just take this as an example, right? I said that power is a problem. Let's focus on natural gas turbine plants within, say, 50 kilometers. It isn't really that expensive to drill, another little pipeline, a gas pipeline to get it somewhere. But so you want it relatively close. You want good transmission lines, about a 250 kilovolt line or more, maybe within a little closer, maybe 10K, and good broadband. Now, I used to do this for a living a long time ago. This is really simplistic way to look at it. You folks are much more expert than I am. But just take that as a simple way to go about it, and this is the answer. So if I was locating a data center and I wanted to attract, I would be looking in Fayetteville, Goldsboro, and a few other places, Gastonia, because of all those factors. You got a natural gas turbine plant, high transmission line, good fiber backbone. I don't know about the land availability. That's up for you folks who are economic development directors. But if you're not thinking of it this way, that's kind of what I wanted to introduce, is the fact that you've got to put all of these factors together, as well as a few others which I'll allude to. So go back to this. Where are you going to locate? Well, there's a couple of good places that I think are optimum locations for new data centers. It isn't really a difficult problem. I'd say the more difficult problem is permitting, land acquisition. Time to build is at least 18-month proposition just by the time you permit it and build it. Attract people. Again, you want jobs, but you need qualified workers to build these things. Not in my backyard is one of those things that has raised its ugly head because apparently these things make a little bit of noise. And that's the other reason why a lot of people want to locate in a more rural area out in the country. Reliable and resilient power, again, maybe gas turbines in conjunction with solar is a good suggestion. The other source that I didn't really talk about is small modular reactors. That's nuclear power. If it takes 15 years to build a nuclear power plant, that's not going to happen anytime soon. The prospect of small modular reactors is out there. It probably won't be economically valuable for another 5 to 7 years, but think of a nuclear submarine. Small modular reactors have been around since the 1960s, right? This is what they're talking about. And they're talking about running these SMRs in parallel. So if a data center expands, okay, here's another 100 megawatt SMR. And then you add another one if you want to expand. But again, the economic viability probably won't be there for another few years. But there are companies right now investing in small modular nuclear. Again, look at the hyperscalers. They are actively, trying to get the bigger electrical companies, Duke, Dominion, to generate and build more nuclear power. Perhaps the current administration is more favorable for permitting. We don't know, but again, 15-year time horizon is still a long way off. So to backfill, you're going to need solar, you're going to need wind, you're going to need gas turbines, and maybe SMRs. And then the last point is access to broadband. I don't know what the availability is of FCC BEAD money is in your community, but again, you need good fiber backbone in order to get that, to get all of the elements in place. So, good luck. Happy to take any questions. Yes, ma'am.
There are two, well, no, there's one, no, there's two data centers in Rutherford County.
And where?
In Rutherford County. There's Facebook as well as a backup for the state. On the resilience piece, are they actually looking, are the data centers continuing to look
I would think resilience, which I mentioned, is one of the bigger things. I will mention this because just before I presented, I noted this. So this is a report by CBRE, the old Coldwell Banker. Whoops, it's not coming up. So CBRE puts out a report every year. Apparently, they mentioned the Charlotte or Raleigh area as being one of the top areas for data center builds, and the data is right below here about the available capacity. Generally, it was considered a build to suit. Now they're doing data center builds on spec. Apparently, 125 megawatts under construction. Again, that may be one data center that's going to be required for AI. We're thinking now in terms of, multiple 100-megawatt data centers out there, like the one that Meta is building. You've probably heard of the one that came together with SoftBank, Oracle, and OpenAI, not Starlink. They've just secured land in Abilene, Texas, to build. We're talking large parcels of land that are being required. Any other questions? Yes, sir.
Yeah, are you familiar with any research or development that's being done on constructing data centers in the spaceborne ones, satellite?
In what?
With using satellite technology? I mean, it just seems like this kind of application seems like sooner maybe rather than later could be something.
You mean using remote sensing?
No, I mean
Or you mean satellites? Oh, I've heard of it. Oh yeah, no, that's speculation too. Put data centers in space?
Mm-hmm.
Yeah, no, I've heard the speculation.
I'm just wondering because the number of the requirements seems like
Yes.
it could be
Yeah, because you'd have ready access to solar, right, up in space.
for one thing, yeah.
Yeah. In the back, sir.
So one of the selling features of these data centers has been employment. Do you have any numbers of whether or not these data centers that are being created are creating real sustainable employment, or are these just a blip once it's created and then there's only a minimal amount of employment that can maintain?
So I'm suspecting you know the answer to that. Because that's one of the issues, right? Is that you get 500 construction jobs, then you build it, and then they all go away. So to sustain a data center, no, it's not that many jobs. You may be talking 50 to 100 people per data center. But I've heard that that is the requirement on a data center. It's not that many people. But, to build it, yeah, that'll be a short blip. But again, economic development directors may want to take that money. Yes, sir.
Yeah, I noticed that you didn't include Apple on your presentation, and I know they have a couple data centers in Maine.
In Maiden, yeah, I showed that. I did show that slide.
Oh, I thought you said Microsoft. Oh, okay.
The first slide I think was Microsoft, or the first slide was Google, then it was Apple's, and I showed the one that had the adjacent solar farm.
Oh, okay.
Yeah.
So the demand for AI, the reason why it's so much more extreme is what, machine learning? Is that what the requirement is? I mean, why is it so much more, such a bigger draw or need for power?
So today's CPUs are not powerful enough to generate the LLMs, to be able to, so it all comes down to data, right? So in order to create these LLMs, there's a tremendous amount of data. And again, to refer to GIS, we're very familiar with lots of data. So this is the issue. The more data you have, the more you can figure out that you would train the model better. So the way I have used ChatGPT and Microsoft Copilot is I'm using it now in place of Google Search. And so in order to get to that point where you can think of you're getting a reliable answer, data in has to be good and reliable and a lot of it to be able to even ask a simple semantic query like, hey, I'm looking for a job in Raleigh, North Carolina that needs a GIS person. I mean, that's you need a lot of data. So a lot of data and a lot of compute power, speed, right? You want that query created quickly and then, That's the reason.
Horizontal versus vertical. I mean, it's like a kid going to get an education. Obviously, the more data he's got, the more knowledge or skill set he should have, and that's what we're trying to do.
It's more data, but then if you're using an LLM, you're only doing one part of what is considered AI, right? So machine learning, again, in my day, when I was doing remote sensing, it was called image classification. It's really machine learning, right? I mean, you're taking a lot of data, you're classifying it, you're spitting it out, and you're letting the computer take ownership of what, again, a classification algorithm or whatever your query is. But it's a lot of data, a lot of compute power. So the chips, the GPU chips, not the CPUs, but the GPU chips, the graphic processing units created by a company like NVIDIA or AMD, they're the ones that are creating these chipsets that are requiring 10 times the electrical capacity to generate the LLMs and then eventually the other models.
So the real problem you got is, let's take Iredell, and they got finite power source, right? And capacity is the capacity until they generate more. And you got business parks going up, and you got manufacturing that come in and create 300 jobs.
Yes.
Okay, we could take, all the power is gonna have to go to something that creates 5 jobs versus,
Yeah.
so and so.
Yeah, and you raise a good point. The electrical demand on AI data centers is going to compete with EVs, with home electrification, and all the other things where we're expecting to make the energy transition. And water, yes, correct. Water is a huge part of it that we're not considering, but again, another input to GIS. Okay, I think I've run out of time. I appreciate it. Appreciate your attention and your questions. Thank you.